All right, a couple of things you need to notice. Yes, you will condense this side through multiplication because you have a plus sign right there. But you also have to recognize that you have a 2 in front of the natural log. And anytime you have a number in front, that's an exponent. Remember, it's a power to a power multiply the powers. So if you expand it by taking the cute little exponent and dropping it down front, to condense it, you put it back. So this 2 is going to go up right here. So I have the natural log of 2y plus 2 squared equals this 2 has to also go up, and then we will also condense them. So it looks to me like I have 16 times y minus 2 squared. Now, you can drop the natural logs right now, or you can wait until you FOIL everything out. It's not going to matter. You should be able to tell me that 2y plus 2 squared is writing it twice and FOILing would be 2y times 2y is 4y squared. 2y times 2 is 4y, excuse me. The 2 and the 2y is another 4, making 8. And then 2 and 2 makes 4. It may have been more simple just to write it out, y'all. I'm sorry. It's getting late and I've had a long day. So 4y squared, shoop, that was this one. And then there's that one, that's plus 4y, that's plus 4y, and that's plus 4. So that's where the 8y came from in the middle, in case you were curious, because I was just verbalizing and not actually showing you. So then over on the right, y minus 2 squared is y minus 2 times y minus 2, which is y squared minus 4y plus 4. Y squared minus 2y minus 2y, and that makes the negative 4y in the middle, and then positive 4. So all of this has the 16 next to it. So this one over here on the right-hand side would be 16y squared minus 64y plus 64. Okay. We finally have one logarithm and one logarithm. We get to drop the logarithms. We have a whole big mess of a whole bunch of variables, but you should have a trigger. Your clue is that you have y squareds and y's. So let's get them all together, because then we're going to factor. So I'm going to subtract 4y squareds. I'm going to subtract 8y. I'm going to subtract 4. So 12y squared minus 72y plus 60. There is, in each of those, if I'm going to continue factoring, there's a 12 that can come out of that. 12y squared is 12 times y squared. 72y would be 12 times negative 6y, and 60 would be 12 times positive 5. So then 0 equals 12, and then I can take what I have left and factor to finish. The factors of 5 that give me negative 6 are a negative 5 and a positive, a negative 5 and a negative 1. So when I set all of these equal to 0, well, 12 equals 0 doesn't make any sense. No x, no answer. It's just a stretch, right? Y minus 5 equals 0, so y equals positive 5. And y minus 1 equals 0, so y equals positive 1. Okay, we can't check this one because it's not an answer in the first place. We do need to check the 5 and the 1. Here we go. Whew, that's a lot. That's a mess. I'm going to need, I'm kind of tempted just to type it in when it gets this complicated. I'm going to do it. I'm going to show you how to do that one more time. Even though I totally could do that by hand, and I've already proven to you that I can do it by hand, of course. I just don't want to. So I'm going to say we're going to store in 5 for x. It's okay that you're using x versus y. It doesn't make a difference. So we're going to store in 5 for x. Okay. And then I'm going to type 2 times the natural log, and the natural log has its own button with the e attached to it. 2x plus 2. That is supposed to equal the natural log of 16 let's get out of there, plus 2 times the natural log of x minus 2. True. 5 works. So now I'm going to store in 1, and I'm going to highlight and copy. So I'm checking x equals 1, or y equals 1, I guess is the equation. Copy it. Ooh, we got a problem. There's the false, so it means extraneous. So the 5 works just fine when I put it in the calculator. The positive 1, so here's an example when it's not a negative, it's a positive, and it still doesn't make any sense. In fact, you could have seen that because it's right here where the issue is. 1 minus 2 is negative 1. And if you can't take the log of a negative number, you can't take the natural log of a negative number either. Last example, if you're still with me right now, kudos to y'all for sticking it out to the very end because this has been a long lesson. 10 examples of some really tough problems. It's a big deal. I get that. Okay, here we go. So we start by noticing these 1/2s. They need to go up where they belong because they're cute little exponents for a power to a power. So we have log base 3 of c plus 1 to the 1/2 plus log base 3 of c minus 4 to the 1/2. And that's going to equal log base 3 of 6. That's a 3. I'm making it worse. So you notice, I'm hoping that you notice, that the 1/2 power, remember, that's really a square root. Both of those are square rooted. And whenever you condense through this addition right here, you're condensing through multiplication. And when they both have a radical, you can put them both together under the radical. So as complicated as it looks, that just ends up being the square root of the c plus 1 times the c minus 4. Now, I might have to FOIL all this out to end up using it, but that's fine. It's fine for now, just left like that. So we have the logs on both sides. We get to drop them. Oh, look, I was right. Okay. So we've got, let's see, I'm going to go ahead and do it. C squared minus 4c plus 1c is minus 3c. And then 1 and negative 4, minus 4. So this equals 6. Not a problem. You did solving radicals like this in Unit 7-8. It's been a while, but it was this semester. So we're going to start by getting rid of the radical by squaring both sides. Got to keep it balanced. So the square root and the square cancel, and you have c squared minus 3c minus 4 equals 36. Well, I've got c and c squared, so the odds are I'm going to have to factor. So I'm going to get everything together on that side. C squared minus 3c minus 40 equals 0. The factors of 40, negative, that give you negative 3. A negative 8 and a positive 5 would FOIL back out to get that negative 3 in the middle and that negative 40 on the end. So then when I set these each equal to 0, I'm going to add 8 and subtract 5. So I've got c equals 8 and c equals negative 5. Let's check them. It's tempting to just go for the calculator again. But that's okay. Let's make sure you see how to do this in case you don't have a calculator on that part of the test or a quiz or something like that. So 8 plus 1 is 9. 8 minus 4 is 4. You can probably hear Bennett in the background. Kevin should be getting her because it's bottle time. And I'm so sorry. I'm not going to restart the whole video for that last part on the last problem. I'm so sorry, y'all. Okay, so what do we have? We have different ways of doing this. Okay, so the 1/2 can go up with the 9. So log base 3 of 9 to the 1/2. Well, that's really the square root of 9, right? 9 to the 1/2. So the square root of 9 is 3. And in here, this 1/2 goes up there. So we've got log base 3 of 4 to the 1/2, which is really the square root of 4. The square root of 4 is 2. And then we have log base 3 of 6. Check it out. When you condense them back to one logarithm, you have to multiply, and 3 times 2 is 6. So the 8 totally worked just fine. Now, the beauty of the negative 5. Automatically going to be extraneous, because as soon as I put it into the problem, I begin with the log base 3, 1/2 log base 3 of negative 5 plus 1. And negative 5 plus 1 is negative 4, and you can't take the log of a negative number. Boom. Okay, you made it. I'm proud of you. Thank you for sticking with me. If you made it this long, you're doing great. You're going to have to practice. But I have full confidence and full faith that you can do this. So, talk to you soon.